Alright, so we want to solve the following equation. The integer part of x squared plus 1 is equal to the integer part of 2 times x. So the red brackets here means the integer part or the floor function. Alright, so to begin with, if a and b are two arbitrary real numbers, so a and b, two arbitrary real numbers, so to say that the integer part of a is equal to the integer part of b is to say that the distance between a and b is strictly less than 1. So I repeat, a and b, two arbitrary real numbers. So if the integer part of a is equal to the integer part of b, then we can deduce that the distance between a and b is always strictly less than 1. So for example, we know that the integer part of 5.1 is equal to the integer part of 5.9 is equal to 5, which means that the distance between 5.1 and 5.9, which is 0.8, is strictly less than 1. Okay, and now we are going to use this property to begin with the solution. So, if the integer part of x squared plus 1 is equal to the integer part of 2 times x, so this means, according to our observation here, so this means that the distance between x squared plus 1 and 2x is strictly less than 1. Now, if I now square both sides of the inequality, so I will get x squared plus 1 minus 2x squared is less than 1 squared, which is 1. And this means that x squared minus 2x plus 1 squared minus 1 is less than 0. And now by factoring the left-hand side of the inequality, we will get x squared minus 2x as the first factor and x squared minus 2x plus 2 as the second factor. And if we start by taking a look at the second factor here, so it can be rewritten as x minus 1 squared plus 1, which means that this factor, the second factor, is at least 1, which is obviously strictly greater than 0. So, in order for the left-hand side to be strictly less than 0, then the first factor has to be strictly less than 0. And this is a very easy inequality to solve. It gives us that x has to lie in the open interval 0, 2. So, in other words, what have we done so far? So, if this equation here is solvable, if this equation has a solution, then the solution has to lie in the following interval. So I repeat, if this equation has a solution, then the solution has to lie in the open interval from 0 to 2. All right. So if we keep moving now, if x belongs to the open interval from 0 to 2, then the integer part of x can only take two values, namely 0 and 1. And we will see later why we are doing this. So if x lies in the open interval from 0 to 2, then the integer part of x can take two values, namely 0 and 1. Now, moving forward, if x is any real number, then x can be always written as the sum of two components, namely the integer part of x and the fractional part of x. So the integer part of x, as it sounds, is an integer, and the fractional part of x is a real number that lies in this semi-open or semi-closed interval from 0 to 1. Okay, now to the crucial part of the solution. The integer part of 2 times x is either equal to 2 times the integer part of x under the condition that the fractional part of x lies in this interval, and it is equal to 2 times the integer part of x plus 1 if the fractional part lies in that interval. And this is not too difficult to prove. So by using this one now, the equation, our equation from the beginning, turns into this equation. So we have two different cases to take care of. All right, moving on. So, since we have this new equation, either equal to this or equal to that, and we know that the integer part of x can take two values, 0 or 1, which means that we have four cases to take care of. The first case is when the integer part of x squared plus 1 is equal to 2 times the integer part of x, which holds under this condition. Okay, and now we try with the integer part of x is equal to 0 first. So if the integer part of x is equal to 0, then we see that the equation becomes 0. But this is impossible. And why is this impossible? Well, simply because x squared plus 1 is always greater than or equal to 1. But this means that the integer part of x squared plus 1 is always greater than or equal to 1, which is strictly greater than 0, and thus we cannot have equality here. So in this case, we have no solution. All right, the second case, still we have this equation under this condition, and now we have the integer part of x is equal to its other value, namely 1. So now in this case, if the integer part of x squared plus 1 is equal to 2, according to the definition, then x squared plus 1 lies between 2 and 3, which means that x squared lies between 1 and 2, which means that, since x is positive, that x lies between 1 and the square root of 2. But now we have to check. If x lies between 1 and the square root of 2, then the integer part of x is 1, which is true. And the fractional part of x lies between 0 and 0.414, which is also true. So this is true, and thus the semi-open interval from 1 to square root of 2 is a solution. All right, moving on to the third case. The third case, Now we have this equation which holds under this condition, and now we let the integer part of x is equal to 0 as before. So in this case, the equation becomes the integer part of x squared plus 1 is equal to 1, since 2 times 0 is 0, which gives us, according to the definition, this, and then this, and then this. And we see that if x lies between 0 and 1, then the integer part of x is 0, which is true, and the fractional part of x lies between 0 and 1. But we have to take into consideration this condition. So which means that this condition combined with that gives us that the solution lies in the following interval. So this interval is a solution as well. Now moving on to the last case, we have this equation under this condition, and now we have the integer part of x is equal to 1. So our equation becomes this, and according to the definition of the integer part, so we get this, and then we get this, and then we get x lies in the interval square root of 2 to square root of 3. So if x lies in that interval, then the integer part of x is 1, which is true, and the fractional part of x lies between 0.414 and 0.732. But we have to take into consideration this, that the fractional part is at least 0.5. So combining this and that, so x will belong to the interval that starts with the point 1 plus a half, which is 1.5, which is greater than square root of 2, and stops at square root of 3. So this interval is a solution. So finally, the set of solutions to the equation consists of the union of those three intervals, which means that it is this interval. So thanks for watching, and feel free to comment.